Okay, we're gonna do a little review.
Can't do it.
How do you do this problem?
Can't do it.
Why not?
Because the indexes are not the
Very
same.
good. So yesterday we learned that when you are, what do we do, what operation are we performing on this problem? What are we doing? Are we adding?
Finding
Oh,
radicals.
We're multiplying. And we're multiplying, and what are these things called right here?
Indexes.
Indexes, good.
Yeah.
This is a cube root, and what's this?
Square root.
Square root, good. And what are these two numbers called?
Radicants.
Radicand. You guys are smart. So why can't we multiply these two together?
Because the indexes are the same.
Very good. Now, what if these were the same? What if I changed this to a 3? What would you do then?
Ooh. No one else to see that?
And what would your answer be?
Cube root 8.
You would be it'd be the cube root of 8,
2.
or what would you do? I would leave it as 2. That would be 2 times 2, and this is a 2. And you are looking for 3 of a kind, right? And there I can steal. I need a 2 here. This needs a 2, so I'm going to steal that 2 there. And so your answer would be a 2, right? So what we learned yesterday is if the indexes are the same, we have the right to take, multiply them, take from the other, and we can combine them and simplify them, right? Well, today what you're going to do is you're going to divide. So look at your notes. So what do you think you're going to do in a problem like this?
You can't do it?
Very good. Same principle applies. If the indexes are not the same, you will not be able to do this problem. But if they are the same, if I change that to a 3, now you can do this problem. Okay? If the indexes are the same, you will be able to go ahead and simplify it. All right? So the first thing that let's look at the property. By simplifying, combining radical expressions, look at the property at the very top. I know it's hard to read. Brett, can you see this on the
Yes.
Sorry.
No, I could definitely see it on the
Okay.
camera.
These mean the same thing. It's blurry?
There you go.
So, what this means is, if I gave you the cube root of 4 over the cube root of 12, it's the same thing as the cube root of 4 over 12. Do you guys agree with that?
Mhm.
Now, why would we want to combine these two?
To treat it as one.
Mm-hmm. What would we want to do with 4 12ths?
Simplify.
Mm-hmm. Reduce that fraction, right? What is 4 12ths?
1/3.
1/3. So you're going to reduce your fractions. That's what we're doing. So the first thing you're going to have to realize, though, is with fractions in radicals, we cannot leave a fraction with a radical in the denominator. What we will do is we will rationalize the denominator. You're going to get rid of any radical in the denominator. What that means, you've got to remember, to get rid of a radical in the denominator, you need, if it's a square root, you need another one. If it's a cube root, you need 2 of them. So you always want to look to get rid of that radical by looking at the index and figuring out how many factors you're going to need to complete that set. Do you know what I'm talking about? So for example, let's make up some examples. So if I were talking about the square root of 3, and I wanted to get rid of this radical,
Release the number.
get rid of the radical, what would I need? What's
Square.
necessary to get rid of this radical? I would need another square root of 3, right? Because then that would mean I have a 3. What if I had the cube root of 2? What do I need to get rid of the cube root? I don't want a cube root. What do I need? I need the cube root of
2.
4. Right? Because the cube root of 4 is 2. Does that make sense?
To make sense to me, I write the cube root of 2 times the cube root of 2 times the cube root of 2. I have 3 of the same thing, therefore I can release that number under the radical. That's how my brain sees that.
So if I had this, I need 2 more of these. Now what if I had the cube root of 4? Then I need a cube root of 2.
Now you ask me.
Okay?
Four
All right,
factors
so-
of 4.
So if I had, let's say if I had the cube root of 4, what is 4? 4 is 2 times 2, right? Isn't 4 2 times 2?
Yeah.
So what do I need to get rid of this? What is missing? What's missing?
How many
I
more
would
twos do you
need, I would need this. To have a set of 3 2s. I would need that.
Are you just trying to get it to a perfect cube? Is
Yes,
that all you're trying to do?
that's
for
all you're
every-
trying to do.
Oh, for
that's
every
all.
number.
Well, it depends. Like,
Whatever
what if,
index.
what if it was the 4th root? What if the bottom was the 4th root
Oh, I meant
of,
for like any number under the.
yes,
Okay.
for the denominator, yes. So what if the bottom was the 4th root of 8? Okay, so what's 8? 2 times 2 times 2.
16.
So then you need another
Okay, so what is missing?
A 2.
4.
We need a 2. So you would need a 4th root of 2. That's what you would need. But what if this were a 4? What if this were a 4?
Then you need a s-
Then,
4 root.
then you would need a 4. You would need a 4 here. What if this were a 2 here? What if this were a 2 here? Then you would need an 8 here, right? 2, then we'd need 2 times 2. We would need
Times 2.
times 2. Okay, so you're looking to get rid of your radical in the bottom. So let's do some examples. These are the examples that I want. Some are easy and some are not. So look at number 7. It starts off easy and then they get hard. Number 7 is easy. We've got 3 over the square root of 5. Remember, you don't want any radical in the bottom. You can have a radical in the top, you just can't have a radical in the bottom. So, what would we need to get rid of the radical in the bottom?
Root 5.
We need to put a square root down here. Okay, so, that's okay, but it's not fair. You would be making this fraction disproportionate. You would have to do that same thing to the top. Why? Because anything over itself is 1. So in other words, if you multiply this fraction by root 5 over root 5, this is another name for 1. So can we take any fraction and multiply it? This is another name for 1. Isn't root 5 over root 5 1? Yes. So are we changing the value of this fraction? No. What are we doing? We're getting rid of this radical, but what we're doing is we're redistributing the radical to the top. Okay? So what is this down here? What is root 5 times root 5?
5.
It's 5. So we no longer have a radical in the bottom, which is what they want us to do. They don't want us to have a radical in the bottom. What do we have? We now have 3 root 5 on top. Does this make sense?
Is that your answer?
That's your answer. So the answer is 3 root 5 over 5. Now if, another thing that could happen is these two numbers could be reducible. They're not right now.
The next one.
So they're, yep, the next one's gonna happen that way. So look at number 8. Sorry, I forgot the dot there. Put the 8 dot. Because sometimes it's 8 times, it's not. Okay, what's wrong with number 8?
That's okay.
We have a radical in the denominator. So we gotta get rid of root 6. We're gonna multiply this by root 6 and the top by root 6. Okay,
So,
Yeah.
why wouldn't you be by root 2?
by root 2,
Because
because you wanna get rid of this.
Because you'll get 12 and 12 is the
Index is 2, so you need a group of 6. You need a group of 6 that equals the index.
Now, why
No.
are you saying root,
Because it's, you, when-
She's using square
Cause
root.
before, yeah, cause it's a square root and then.
She did
you
2
need
last
two.
time because it was a 2 and she tried to
Okay.
get a perfect 1. If you do it by 2, then you're gonna get root 12 and it's not gonna, you're still gonna have a radical 12.
I'm confused.
Shemaya, whatever the index is,
Mhm.
and what's under your radical, you want a group that you can pull out and get rid of that radical. So since 6 breaks down to, it doesn't break down into even stuff, just multiply it by a radical of 6. Then when you release that, what is it?
Yeah, you get
It's
this.
6,
I
right?
got it.
That's what you want. You want to release that number or a factor of that number that makes up that group.
Now, this is an interesting problem because you're gonna end up with 2 root 6 on top. Okay, and then you have a pair of 6's here, so you have a 6. But like what Sam said, she said like this one, see these two, you can reduce. These two are like terms, so you can reduce 2 goes into 6 3 times. So this final answer is root 6 over 3.
Can you put them on like it does?
Mm-hmm, yeah. Mm-hmm.
Those
It's
invisible
not like
ones.
plus or minus.
No. You're not solving an equation, no.
Yeah, but it seems like every time we move on to something else,
I know.
every time we like go
Yeah.
back to factoring.
I
it's like,
know.
oh.
I hate that.
Okay, number 9. Before another thing can arise. You might want to simplify a radical before you rationalize, like this one. Can anyone, you could rationalize first, but can you simplify? What do you see that you can take out first? Yeah, see this right here?
Yeah,
There's a lot of
Three.
factors in 18. So, off to the side here, if you thought about the square root of 18, 18 is 2 times 3 times 3 times x. We can yank out a 3. Does everyone see that? So, in the bottom, we've got a 3 that comes out. It's ready to come out. And what's left is the 2x. So, are we all on board with what I just did?
Yes.
We had a group of 3s that came out. Now, we don't want radicals in the bottom, so we need what's missing to group up? What are we missing? We need a 2, we're missing a 2 to complete the 2's, and we're missing an x to complete the x's. That will complete this set. And you just need to complete that by taking care of that on top. Whatever you, always remember, whatever you do to the bottom, you do it to the top. So, who thinks they know what the top is gonna be? You got it. Nick, say it.
Root 14x.
Root 14x over,
6.
you got it, 6x. You got it. You got a pair. You wanted a pair, and you got it. You take it out.
How did you get 6x?
How did you get 6x, Nick?
The radicals are gonna cancel, so you're gonna get 3 multiplied by 2x, and then just multiply 6x.
Okay, do you know where the 3 came from? You know where the 3 is?
Factor the 18.
The 18, you got the 3 from the 9. 9 times 2, that's the 3. The 2, we needed, we put a root 2x here. So we've got a pair of 2's. We have 2 times 2, so we have a set of 2. So you take the 2 out and you merge it with the 3, that's where the 6 comes from. 2, you have a set of 2's, so you put it with that 3 and that's where the 6 comes from. So 2 times 2, so it's actually like root 4, which is 2. Square root of 4, which is 2. 2 times 3 is 6. And then you have a pair of x's, which is just an x. That,
Anytime you have a square root radical times a square root radical, it releases what's under it. So that says 3 times 2x after that step. And that's how you get 6x.
I have a question.
mhm.
So what you did before, like on the blank sheet of paper, like how you were like using different numbers that equal the same thing, was that because you had like a 3 and a 4 as the index and not a 2?
Yeah.
Like every time there's a 2, it's just gonna be itself, and then
Mhm.
there's a 3 and a 4.
Oh, okay.
Yeah.
Yeah, you gotta find groups of those
Yes,
factors.
yes,
yeah.
yes.
Good job. Way
Yes.
to talk it up,
Yes.
explain.
Okay, let's do problem 4. It says problem 4. Problem 4. Okay, now let's divide.
Let's
And
simplify.
that's a 6,
Yes.
Can we just
Right?
simplify?
Yes.
Correct.
Anyone think they know what to do?
Simplify.
Simplify first, good. What do you want to simplify?
The 15 x squared and
5 roots, or 5,
Wait, where are you getting 5?
1.
so 10.
10, where are you getting 10?
Okay, so
50.
factoring is 50, right? So what goes into 50?
Wait, wait.
Not that far.
Where are you getting 50?
I don't even know what's going on anymore.
I see a
so-
2 and I see a 50.
Okay, he's using the 50.
Why can't I do both of them? Can't factor both
2
of
goes
them?
into 50 how many times?
25, 5 times 5 is 25.
Okay, so that's what I want you to say
So set of
first.
5 and
25.
2.
Shh, shh, shh.
2 goes into 50 how many times?
25.
That's what I want you to say, 25. And then x to the 4 and x to the 6 is what?
X squared.
There you go.
That's it?
Yeah.
Oh.
But then you gotta do
And then you gotta
simplification of that.
Yeah,
5x.
then you gotta simplify that again.
Now we're gonna simplify that.
Why is it x squared?
You got 6 x's on top
How many times
You
is
subtract
4
and 4 x's on the bottom. You just subtract them like we did
Yeah.
old school. You got 6 x's on top, you got 6 x's on top, and you got 4 x's on the bottom.
So why is this one different than all the other ones that we did? Like the past 3 that we've done?
we had something we could simplify
you have-
before you broke it up.
We're just simplifying. We didn't do any radical stuff yet. We're just simplifying.
And then like.
We're just
The
simplifying.
first ones didn't have
18 to go to
radical
7.
over.
We're just doing the division part. Right, Nick? We're just doing we just did 2 goes into 50 25 times, and we have x to the 6 over x to the 4, which is x squared.
Okay.
That's all we did. That's all I wanted you to do. Right now is the division part. That's all. Now is the new stuff, the radical stuff. What's the square root of 25? 5. What's the square root of x squared?
X.
So that's it. That's the new stuff. Old stuff, new stuff. Easy. Boom. Want to try a new one? Another one? 8.
18.
What you gonna get first?
Where'd you get 9? 2 goes into 18 how many times? So in other words, it's one big radical.
Basically.
It's 18 over 2. X to the 5th over x to the 3rd, right? It's one big radical. 9, bless you.
X squared.
What's the answer? Right?
Yeah.
How about the next one?
Oh, weird.
Ooh.
Looks like 24, it goes into 24.
It's 32 times 3. Oh, I keep trying to factor it, I don't know why.
I looked to see if 4 goes into 96 first, doesn't
Does
it?
4 go into
It does.
96?
Yeah.
24 times.
24.
Okay, so in other words, it's this, right?
24 lines before.
It's 24 y to the 4. So I want to break 24 up. What are the factors of 24?
2,
2, 2, 3, y. So what's the answer? 3, y. What else?
Did you say 3?
I mean 2.
I'm like,
I didn't know if you were
Two
counting
Y.
the number of
Yeah, I
that
was.
before, or- okay.
And I accidentally said it wrong. So what's my answer, guys?
It's gonna be
2y
2y.
cube
cube
root
root
3y.
3y.
I do too. Number 10. What do you do next? Number 10.
27 times it goes in
So what I do is I'll make my fraction here, because it's all the same index. 2 goes into 54, what'd you say?
What you said?
Okay, what about the x's?
Who wins? Top or
The
bottom?
bottom.
How many are left?
X squared.
Looks like we're gonna have to rationalize this one, right?
I'm really excited.
Who wins in the lines? The bottom by 1.
Okay, now, this is one where you're gonna have to do a little operation.
If you
My
know-
operation, what do I wanna operate. I wanna break up the numerator and denominator.
Okay, just
Right?
like cube root is 27.
What do I wanna break up the numerator. I wanna do the cube root of 27. Why?
So that you can simplify it.
Yeah.
Why would you want to work with the cube root? You can just put it
Because the cube root of 27 is
in 3.
3. Now, this is where I have an issue. This is a great
Oh
problem.
my god, no it's not.
Why are you writing the, oh, okay, you're just rewriting. What do you need groups of?
Now, I need to complete. I
So
need
you
to
need-
complete.
So you need
Multiply
a
by
cube root
x.
of x, y squared.
Yes.
Yeah.
I
Get
need,
it.
I'm gonna use my red pen.
Yeah.
That's painful.
Now, before I write on my paper, I want everybody, before I write anything, because sometimes when I write, and you guys get lost. Everybody look up there. Tell me what, I need to rationalize that denominator. What is needed? Everybody look. What's needed to complete that bottom?
And tell us besides
Tell
the
us.
two people who are
XY
talking.
squared.
Just repeat
What?
I say.
XY squared.
XY squared. So
The thing
that's,
is, there's
so
two
I
X's.
need the cube root
So you need three
of
of them.
X, Y squared. So I need cube root of X, Y squared. I need a thumbs up from everybody if you get this.
Oh, Tom's eyeballs.
No.
How many X's do you have on the first round? How many X's do you have?
It's a cube of three on the outside, that's the index.
To the left of the reds, look at the red on the bottom.
There's X
We
squared.
have two X's, right?
Well, you wanna
We
take
have
them
one
out,
Y.
okay?
Because
So X squared.
No, because
we
we have two of them.
So how many X's do I
X
need
squared
to
times
get?
X is what?
Intermission.
Y.
We'll be right back with our notes in
This is
just
what
a
you
few
have.
That's
moments.
why you have X
What other
times
X's?
Y.
This is what you have. I need one more. I need three of them.
The X, what is the X?
I need one, I have two. I need three.
Yeah,
I need
look
one.
at that bottom one.
X squared.
I need one more. X.
Times the X.
It's X cubed.
I'm looking for groups of three.
And you need three X, cause you know how
And I
many
have
factor
one
it?
Y,
X,
I need
X,
two
X.
more.
So when you group that together.
You're just
it's
trying to
X.
find a thing to
So
make
the
that
X
set of
squared.
three, right? You're multiplying it by
I don't
something.
know what you would a single X from, I just see
You
X
come up,
squared
you have to
as
figure
one.
out, that's what you're figuring out. You have to figure out what you need to multiply to get that set. Yeah, that's what that X comes from. The Y, there's one Y, and you need a set of three. So Y times Y squared.
In the red, it's the single X.
Yeah, that's why I said I'm not writing anything until you guys look up here and tell me.
And then you need two more Ys.
So that's why you do Y squared.
Just figuring out what, you're figuring out what else you need to make.
So whatever the index is, you need groups of that many to pull it out.
Okay, see, I got to this point and I simplified. So this is the part where you can't have that, you can't have a radical in the denominator. And it's a cube root. We're looking for sets of three to complete. Remember in the beginning of the class, I said, you're always gonna want, whatever the index is, you wanna complete the set of whatever that index is. So in this problem right here, I need three X's. I have two of them right now. Currently, in this problem, I have two X's. What would give me three X's? What's missing? If I have two, what would give me, if I were playing cards,
2 plus 1.
and I have two X's in my hand, what would give me three X's? What do I need to have three X's?
Another X.
One more X. So in red, I have an X right there, one X. And I have one Y in my hand. What do I need?
Two more X.
Two more Ys. Now in math, you can't do, when you're giving something to the bottom, I have to do it to the to top. Whatever you do to the bottom, you do to the top. Otherwise, your fraction's not proportionate. So what have I done to this problem? I'm not done. I now have, look at this, I now have three X's. Count with me. Two X's here and one here. So now I have three X's and I have three Y's. So on top, my numerator is gonna be 3 times the cube root of XY squared over, I've got three X's, so it's an X, and I have three Y's and a Y. This is your answer. It's kinda ugly, but that's
I don't
it.
like it.
That's it.
Where'd you get this three from?
Cube root of 27 is.
This three right here, yeah, the cube root of 27. Okay, number 11?
Number 11.
Number 11.
15 and 2.
what should we do with this problem?
We should just.
We should multiply by root 5x, because I don't want a radical in the bottom. So I'm gonna multiply the top by root 5x. So I get,
15.
on top, I get 15, and on top I have 15x under the radical. On the bottom,
10x?
You get
I have a 2 out here,
10.
but I have a 5 that's gonna come out,
10x.
so that's 10. And I have an x that's gonna come out. Now see, can you cancel something out here?
Take a 5
A
out.
5's gonna cancel. So what cancels? A 5 is gonna come out of here, I'm gonna get a 3. And a 5 is gonna cancel out of here, I'm gonna get a 2. The x. So all I did was I canceled a factor of 5 and 5 out of here, and everything else stays. Do not cancel these two x's because they're not like terms. One's under the radical and one is not. They're not like terms. Number 12 is difficult. Let's do it, and please be patient, okay? Please be patient with me on this one. If you can do 12, you are a master simplifier. You got this. This is you have mastered this problem. This is the most challenging problem. Number 12. Does anyone think they know what to do with 3 12s?
Simplify it.
Yeah.
Yep.
Do it. 3 12s. 3 and 12, make it
1 and 4.
1 4. What else?
And then 5 and 15.
Mm-hmm. Now, did anybody make one big root 3? This is what I do. I make one big fraction, and I start simplifying it as 1/3, because 5/15 is 1/3. And then my x's, I put x to the 4th on top, right? And y to the 4th on the bottom. Was that hard? Okay, now, what is the index on this problem? 3. What does that mean to you? And is there anything that can come out? We're looking for sets of how many of a kind?
One set of y.
3 of a kind. So what do you take out, Nick?
X and a y.
An x and a y. Where do they go? I've got 1/4 standing outside
So it'll
waiting
be
for
1
something.
x and then
One
Shemaya,
fourth.
what would you put?
1 x and 4y.
Okay, so
On the
Shemaya, you're,
outside. Because it's like
yeah,
that.
you're right. So you're saying next to the 1, you're gonna put an x, right?
Yes.